Hello again. It's Paul Beckwith talking about the nuances of the Arctic sea ice. You know, as we near the minimum this year. As far as the extent goes, it was tracking 2012 and then flattened out significantly. The drop in extent significantly slowed from about the mid-August. But what's very, very important is that the Arctic sea ice volume is this year is still tracking the 2012 volume. So the volume of the ice is still at record low volumes and matches essentially the record low in 2012, but the extent has flattened out. So therefore, in order for the volume to match, the ice has to be a lot thinner than it was before, or the values of the ice in the extent, which is here, okay, so the ice here could just be 15% ice, 85% water, right? And as you go in, you know, if it used to be 50% ice, maybe it's 30% ice now. If it used to be 80% ice, maybe it's 60% ice now. So we're still losing the volume of ice to match 2012, but it's not being recorded it's not being seen in the extent, which is stalled out. I hope that makes sense. Okay, so that's a key factor. These are Arctic temperatures from June to August, and we're statistically tied with 2012. Okay, so we're basically, the 2-meter temperatures in the Arctic are the same as in 2012. So, you know, the idea that maybe smoke from the fires or something in Siberia on the permafrost, smoke from Alaska fires, went up and blocked some of the sunlight in the Arctic to make it colder. That idea doesn't hold, because the temperatures in the Arctic are very, very warm, and they match, in fact, the 2012 numbers. Okay, and I showed this plot here. This is sea ice thickness in 2019 in August. Okay, so these are the numbers here of the sea ice thickness. So there's 2-meter thick, slightly over 2-meter thick ice here in these regions, and then it gets thinner and thinner and thinner. This is basically a 1/4 of a meter thick in the fringes. Okay, that's what that shows. This is Arctic sea ice concentration in from through August, September. This is a very neat plot. It shows basically the zonal mean wind speeds in the different months. So I'll try to stop it at the beginning of the year. There's January. So what you're seeing here is the wind speed is high here, the wind speed is lower here, but look at the elevation. It's at 200 hexapascals, which is the height. What you're looking at here is the jet streams. Okay, you're looking at a powerful jet stream in the northern hemisphere and a weaker one here in the southern hemisphere, and very high winds up here, which makes up part of the polar vortex. And then as you cycle through the seasons, then as you go into the summer, the jet streams weaken significantly in the northern hemisphere, and they strengthen in the southern hemisphere, and you have a very strong polar vortex here, very, very fast winds at higher and higher altitudes. Okay, so you get the asymmetry. So it's really interesting to click through and see what's happening, and you can see as the Arctic warms and warms, that weakens and slows the jet stream. So it slows the jet stream here. And you can see how it affects the southern hemisphere jet streams and things like that. Okay, there's all kinds of other plots and things here, but I think I'll move on to now look at the Arctic Sea Ice Forum. So if you go to Google Arctic sea ice graphs, and you can go look at the forum, go click on the forums, and let's see what the forums are saying. So sea ice area and extent data. You can, this is the most recent one at the end, 49. Go down to the bottom and you can see the previous posts. This is the most recent posts in this site. This is showing the area in the different regions, extent and area. You can go through and there's loads of data. There's stuff is continuously posted on these forums to try to figure out what's going on with the sea ice. And then there's another one here, the 2019 melting season. So let's go to the bottom. Look at the most recent posts. And one of the ideas is that the idea that there isn't enough insulation to melt the ice north of 80 degrees north with the current freezing degree day thickness increase, even in a sunny year. To melt the ice, so what it's saying is to melt the ice, that's nearer the pole, we have to have warmer winters and then get less thickness of ice forming in the winter. And what it's saying is, there's no export of ice when it's above 80 degrees, right? There's no export through the Fram or anywhere else. The insulation is very low because you're right at near the North Pole, so the sun angle is very low, so you get less surface melting of the ice. So you're only relying on the warm ocean melting the ice from below. But there's vertical mixing is prohibited by the halocline, the salt layers. So warmer, saltier water below, colder, fresher water at the surface. So that doesn't melt the ice very quickly. The input of fresh water from rivers and so on is more at the edges of the basin. Okay, what you need basically, it looks like, is big storms. You get mixing occurs with big storms, but they seem to be rare in the summer. So in 2012, if you'll remember, there was something called the Great Arctic Cyclone, and it twisted up the ice, and it sent pieces of the ice from the central basin to the fringes. And basically, it was very important for causing upwelling of warm water by something called Ekman flow, and we had a record minimum year. So what it looks like may happen is that if there's no cyclones, no cyclones like there was in 2012 for a while, then we may get less and less ice, but it might the negative feedbacks might cause the ice to be centered around the pole. And then one big, cyclone, long period cyclone sweeping up in the Arctic could then spread all that ice to lower latitudes where it can melt out and finish it off, basically. So that may be what happens, and that's very, very difficult to predict, when that will happen, when one of these, huge Arctic cyclones will come and rip apart all of the ice. But that might be what is required in order to finish off the ice, while it's in its the regime of being very, very thin, all first-year ice, very little multi-year ice. So that's an interesting possibility. This is a POMAS update on the thickness of the ice. You can look at, this is the thickness of the ice in the eastern on the ESS, Eastern Siberian Shelf, the Chukchi Sea, Beaufort Sea. You can see, how the ice thickness is varying in the different regions of the Arctic. Again, loads of information on these sites. This is the modeled ice thickness, how it's varying from day to day for the August animation, and so on. So, I showed you this sort of plot here of the daily Arctic ice volume. So this curve is showing 2019, tracking very close to the record minimum of 2012. And then you can see the anomaly here, and here we are in the red region. So over here, from July through to August, so the month of July, we were at record low ice volume. Was the anomaly was the largest, and then we crossed over, so that 2012 becomes lower, and this year is a little bit higher over here from about the first week of August to September. Okay, so there's a lot of dynamics going on. This is very interesting. This is showing export of ice, Fram volume export. So basically, in the summer it drops to almost zero here. Okay, drops to almost zero because the ice is retreated back, and you no longer get export through the Fram Strait. You can see that the export continues through the winter. So if you get a winter with very, very high export of ice through the Fram Strait, that can get rid of tremendous amounts of the thicker ice, the multi-year ice, if there's still multi-year ice left. Okay, and I tried to delve into, there's still a lot, like I said, this is a big learning process. So I went to Google Scholar, Googled Arctic sea ice, looked at papers since 2019, and, there's loads of stuff out there. There's loads and loads of papers. It's not possible to read them all, so you try to go through, do a selection, study a specific thing. So here's a paper, Arctic amplification is caused by sea ice loss under increasing CO2. Of course, the albedo is dropping of the Arctic, we know that, so this goes into some of the details of that. And then a conference on climate prediction and so on, lots of Arctic papers, so I was looking through some of those. Modulation of Arctic sea ice loss by teleconnections, so to do with these modes of variability in the Atlantic, and there were coral records, coralline algae, and that gave you an indication of Arctic sea ice decline. This is the effect of Arctic sea ice loss on the Hadley circulation, right? So, under Arctic sea ice loss, ocean heat transport acts to transfer the Arctic signal to the tropics, and that contracts the tropical circulation. So that would shrink or contract the Hadley cell. And because of warming, the Hadley cell is increasing, so both effects can counteract and keep the Hadley cell in place, right? And, loads of other papers, which I'm going through. So as I learn more and more things from these, then I'll convey that information to you. But basically, so where are we at? Have I completely confused you on Arctic sea ice? Have we gone down the rabbit hole? I don't think so. I think if I completely understand something, then I can explain it to you very, very clearly, so that basically anybody can understand it. But if I don't understand it completely, then I think you can clearly tell, because I'll jump from paper to paper, and I'm still trying to, I try to collect as much information, as much as the science, and get it up here, and then it jiggles around, and I look for patterns, and then I can try to find what's going on. And I think the key factor here is the key factor is basically this plot here, right? This stalling out here, and this image here. Okay, so these are the two key factors here that are happening. Okay, the sea ice volume this year is tracking right along the record minimum of 2012, right? And there's no kink in this curve, certainly not in mid-August. It's just tracking, solidly, whereas the extent was tracking solidly and then broke off here. Okay, so that's the key factor. This is certainly not a recovery. There's because the total volume is tracking the record minimum. But, we need to, why is this happening? It could be the north of 80 degree Latitude effect, slowing things, could be a lot of other different factors. So anyway, thanks for listening.